This is the Thornton's chocolate factory where cocoa beans are turned into the chocolate that we all eat.
That's what I think of as chocolate. Smooth. One more.
Although usually delicious, chocolate can sometimes disappoint.
This one's slightly different. What do you notice immediately on the surface?
It's definitely some duller and so a slightly different colour to these two. It's just like if you leave the chocolate in the sun, it melts, and then you try and put it back together again and put it in the fridge.
It's actually quite soft.
Yeah, it is actually. It's not melting on it. So I tasted. Oh, very strange, really chalky, rough texture.
The ingredients within the chocolate are exactly the same. It's actually the crystal structure within the chocolate which determines the mouthfeel and the texture of the chocolate.
To taste good, chocolate needs to be made to have a very specific structure of tiny, stable crystals. It's a process that requires very precise heating and cooling.
You can see that it's all beginning to melt now.
That's right. There's actually 6 crystal formations within the chocolate. Each one has its own melting point. If you like to pass me the thermometer, you heat the chocolate between 45 and 50 degrees centigrade. What this does is melts out all the different crystalline structures within the chocolate. So we see it's going up, and that's absolutely perfect. So what we need to do now is take this over to the water-cooled slab. And what we're going to do is pour 2/3 of that chocolate onto the slab. This is to bring the temperature down really quickly to 27 degrees, and that starts to form crystals, stable and unstable, but it's the stable ones we want, not the unstable.
So this is real precision science and precision chemistry.
It is, very much so. And what you'll see is, as it starts to cool, it will start to get thicker. So I think we're ready for testing the temperature. Yeah, it's getting there up to 27 nearly now. Perfect, that's where we need it to be. And if you remember, we've got that warmer third of chocolate back in there. So by lifting that temperature just slightly, it just melts out any remaining unstable crystals and leaves those stable crystals that we really wanted.
I see, so you're trying to just control it just precisely so you get the one type of crystal that you want. Do we need a cross-check?
I do.
32.
Perfect.
This is brilliant. This is cookery the way I like it.
So we've got the tempered chocolate now. We're going to pour it into a mould. So this is the best bit.
This process of melting and cooling happens on an industrial scale out in the factory to ensure all of the chocolate contains stable crystals and tastes great.